Hey guys, welcome to the Joe Jaguar Show again, your best friend in astronomy. And remember, I don't just talk about theory, I actually test them, and that way we actually know. Because sometimes what is theory doesn't always apply to real science. Just like Mythbusters. Until you actually do them side by side, on the same day, same power, same object, you can't guess. You can't test one a month ago or a year ago or just whatever people say on the forums. Doesn't work like that. Anyway, before we get started, I actually wanted to do a test of 4 different telescopes, but I don't have one. So we're going to do a test of 3, which is still an amazing test anyway. But before we do this, I got an astronomer that's going to blow your minds away. And he actually knows everything there is about astronomy and science and telescopes, even knows more than me, okay? Way more. Let me go get him. Hey everybody, this is Joey, and he is the expert. Hold on a second. This is Joey, he's the expert. He actually knows English, he knows how to talk, he knows how to speak, but I'm not sure if he's gonna say anything. Okay, I need your help today, because we have to test these 3 telescopes. And I need an expert that knows everything there is, okay? So what do you say? You're going to help me do this test, okay? So first off here, this black long one. This is your traditional telescope, which means this is what they've sold in the 80s, 90s, 2000s, and they still sell it now. Now, the thing is, I've heard people say that all telescopes that have spherical mirrors are bad or crap. And that is not true, okay? These big long ones, so we're testing 3 4.5 inch. So this is a 900 millimeter, this black model here on my right. It has a spherical mirror, but it's at f8. So the image quality is actually pretty decent. Okay, Joey, we're going to, yeah. He wants to go now. Every company has it, and it's very popular. And keeping a spherical mirror in it is going to keep the price down. So having a spherical mirror in here doesn't mean it's a bad telescope. As they read on the forums, spherical mirror type of thing. There are certain models with spherical mirrors that are going to be good, and then there are some models with spherical mirrors that are going to be bad. However, this being the traditional long, so if you have a spherical mirror in an f ratio of 8 or to 10, the image quality is going to be pretty good, okay? So it is a misconception that all telescopes with a spherical mirror is bad. Okay, over here we have the Celestron Nexstar 114 millimeter. This is a 4.5 inch, so identical to that one, the black one, except this is what they call the Burge-Jones design. So it has a spherical mirror, and then what they do, this is 1,000 millimeter focal length. So how does this model achieve 1,000 millimeter focal length when this one is way more, like double the size? So what they do is they put a Barlow lens inside the bottom of the focuser. It does, it's like a 2 times Barlow or amplifier, and that will, so theoretically, this guy should be 500 millimeter focal length, but with that 2 times amplifier, makes it 500 times 2 is 1,000 millimeter. Now, so in this instant, this model is going to be inferior to that model or a model with a parabolic mirror. So what they're trying to do is very similar to this guy. This guy has a spherical mirror at f8, right? It's 900 millimeter focal length. So what this company's trying to do, because they know, or all these, it's not only Celestron, a lot of companies make these Burge-Jones design. So what they do is, because in this size, the 4.5 inch size, is probably somewhere between $80 more than a spherical mirror. So that's going to make the price jump up. So what the company will do is use a lower quality spherical mirror, put it in a 500 millimeter tube, just try to put a 2 times amplification or Barlow in there to try to copy the focal length of that guy. So this makes it 1,000, even 100 millimeter focal length than this guy here, right? This guy here. Edges are very soft and they're not as sharp as like that one. So next, we have almost identical to this guy. It's a 4.5 inch reflector and 500 millimeter tube, but this one does not have the Barlow in the focuser like this one does. So this one is not 1,000 millimeter focal length. It is just a 500 millimeter telescope. But this model does have the spherical mirror. So there's kind of like 3 versions of these. So there is a 4th model, and it's this size here, or the size of these two. 4.5 inch, 500 millimeter focal length, but it has a parabolic mirror. Of course, it is more expensive. As I said, that version is, I think, the best of the 4, but it is more expensive. Like I said, it's at least $80. And again, for those people that don't know, when I talk in money, I'm talking about where I am in Canadian. So it's about $80 to $100 more than these 2 or these 3 versions, right? So we're not going to go by theory, but I don't have that one here. Unfortunately, it's hard to keep buying every type of different product out there to make a video. So that's why I was saying I would have liked to do a test on, again, the old traditional long format reflecting telescope with a spherical mirror. Then you have the Burge-Jones design, which is a 500 millimeter reflecting telescope with a 2 times Barlow, amplifying it to 1,000. And then you have this new version that's, they don't put the Barlow in this one, but to keep costs down, they still give you this spherical mirror. And then again, the 4th version is the exact duplicate of these 2 with the parabolic mirror. Of course, again, I don't have that one. I would have liked to, but it is what it is. So I'm going to compare these 3 and which one is the best out of these 3. So if you guys had to choose this model, or that model, what of the 3 is going to give you the better view? Which one would be 2nd, 3rd, and 4th in this case? But remember too, that parabolic mirror is going to be $80 to $100 more. And sometimes that is going to put beginners out of the price range, because a lot of times they don't want to go to like $300 to $400 for a starting telescope. For instance, one of these ones, the Burge-Jones design, or maybe that one, is probably going to sell about $299 Canadian retail. Now with the parabolic one, it's probably going to be $399. Anyway, so that's it for this part. I'm going to put them each at the same power, same item, same night, because even seeing conditions or the atmosphere is sometimes unsteady. So you can't test them one night, one the next night, and one the night after that. It won't work. You have to do it on the same night, because whatever the seeing conditions is going to be, if it's lousy, average, or amazing, all 3 are going to be working at that environment. Every night can be totally different, just like the temperature, humidity can be different every day, and the wind. So you cannot test them one at a time each day. They gotta all be on the same night. So I am going to do that for you guys. Anyway, we'll be back in the conclusion. Hey guys, so remember this telescope? The 4.5 inch. Remember the 6 inch that was all scratched up? The video I did a few weeks ago. This was the 4.5 inch that I ordered, and it was supposed to be 4.5 inch, 500 millimeter spherical mirror, and they sent me because they have 2 models, 114 millimeters, 1,000 millimeter focal length. And that was the small problem that I mentioned, that they sent me the wrong version. And what they told me is Yeah, that's my meteorite behind here and my books. I'll show you guys my meteorites another time. But anyway, they told me if I just take that Barlow lens out, then it becomes 500 millimeters, the same telescope. So I tested it yesterday, and it does not focus without that Barlow lens in there. So basically, that video again is screwed because now I have two Burge-Jones design and one long format, 4.5 inch f8 reflecting telescope with the spherical mirror. So I wanted a third. This was supposed to be a spherical one, but at f5, then an f8, and then a Burge-Jones design. So this kind of screws me up because I have two Burge-Jones designed in, and I don't need that. So it messes me up. So now we're only going to be testing two. So again, they messed me up, but I'll just keep continuing with the video anyway. Hey guys, so as you saw by the last little clip right now, we're down to two telescopes we are testing. A long version, 4.5 inch reflecting telescope, and a short version Burge-Jones design. What's nice is it's almost 9 p.m., which and it's May 10th, and it's just starting to be, sunset was just a few minutes ago. So in the northern hemisphere, the sun sets, fairly late. So, which is good because it's not quite dark, so you guys can obviously still see me fairly well. It's not completely dark, but let's take a look at the moon. The cell phone, that's 9 times. Okay, anyway, so let's get back to business. So let's just try to look at the moon here. And there's focus. We're going to use the same eyepiece in both. This one is 900 millimeter focal length, and this one is 1,000 millimeter, but they're practically going to be virtually same power, within very close. Wow, you can see lots of craters. This is only a 32 millimeter eyepiece, so it's really low. Okay, now let's go into this guy. Not sure if you can see, I'm just out of the frame. Okay, hold on. Let me get these a little closer. Okay, so I have it in the eyepiece of this one. I mean, most people complaining about the Burge-Jones design, I can see every crater fairly well. Looks still pretty good. Let's do a fair comparison. Let me take another look, a second look here. It's not bad. Let me go higher power. And I'm going to focus on the terminator so that way I can see like the craters. Okay, so if I was somebody brand new, that looks pretty good. I'm only using like a super palazzo, the Meade 4000, so nothing crazy that new people wouldn't have. It's a 52-degree field of view. I don't have any tracking system on here. I'm looking inside a big crater, and I see a row of craterlets, almost like in a spiral, like a circular thing. Let me see. Yeah, I can see it here too. Okay, yeah, okay, I see a little difference, but it's not bad. Okay, you know what, guys? Now, I have used a different Burge-Jones design where it wasn't as good and sharp. Maybe the collimation on that one, or maybe the figure of the mirror was a little worse. It was a 127 millimeter Burge-Jones, and I found it a little mushy. But, if your collimation is good, it's actually not that bad. So, a lot of people bad-mouthing the Burge-Jones design. Now, mind you, maybe if one is made really bad, then it's not so great. But if you have one that's made pretty good mirror and figured pretty well, and you're collimated pretty good, the views out of the Burge-Jones is actually pretty decent. Like, you know what I mean? I know I've also said it on the channel as well, that the Burge-Jones is a little bit less inferior, but it's pretty close to this long version one. I would say only 10% difference. So maybe the long version is just edging it out a little bit by maybe 10%, but it's really not that bad. I mean, so if you guys are you know, maybe we shouldn't be bad mouthing it is, because you know the Burge-Jones design is cheaper for the new person. And if that's what's going to get them into hobby, if somebody was to look in there and most new people, they'll probably see zero difference. Now, if you're maybe experienced a bit, you can say, okay, this one's a tad sharper, but I think I cleaned this mirror and then I collimated it, so maybe that helps too. Where a new person maybe doesn't know how to collimate as well, type of thing. But the image in here, I think any new person would actually probably enjoy. But again, you know what I'm wondering? Now, that other one that they sent me that was wrong, you know, because the other one was supposed to be a 500 millimeter spherical mirror, short tube, so that way it's one of each. Since it doesn't work without the Barlow and the focuser, I wonder, maybe I should do another video. If all Burge-Jones designs, are they all equal? Because this one I find fairly good. The image is pretty well. I don't think any new person is gonna like say, Burge-Jones is crap. I think they'll like it. But I wonder now, could I take a good Jones bird design against that crappy one that I got from that factory? And I wonder if the images, and remember, we're talking one that's about, you know, 5 or 6 years old, roughly, to a brand new one. You know, so that definitely has the advantage there. So I wonder, will a cheap quality Burge-Jones design, even though this one from Celestron is still made in China, even the same factory, but I wonder if, you know, the Celestron and all the big names, what they do is when they test it, they make sure it's 1/4 wave. I guess for the new people, what that means is the big name brands, they test it at a certain point to see if it's good, and if not, they rejects, and then these new really cheap companies will even buy the rejects and they'll still make their own telescope. But let's do another video. This one, since this one seems to be performing fairly well, so maybe it was figured very decent against that other Burge-Jones design, and let's see if there's a big difference. We'd be curious to know. Maybe they're going to be identical, you know what I mean? Or maybe there's going to be a big difference, and then that way I can get back to you guys and let you know there's differences in Burge-Jones design, and maybe that's why a lot of people bad-mouthing them, because maybe they got the bottom of the barrel kind and it was really bad. Maybe they never got a decent quality Burge-Jones design. Now, mind you, I understand the quality is going to be a little less, but it is a lot cheaper. So, you know, it is what it is. You get what you pay for. If you're on a budget, you know, I had to start somewhere too. And actually, when I started in '93, it was probably something like this, a short tube reflecting telescope. And if somebody was to tell me, no, don't buy that, you know, because I think back then it was like 150 bucks used. But if anybody was to tell me, no, don't get that, you got to start at least $500, $600, or $700, I probably may not have started in the hobby. That probably would have been too much, where I would have said, I can't do it. It's too much for something I don't even know if I'm going to enjoy yet. So take that into consideration, guys. The new people, they got to get their appetite wet. They got to thirst for something. They got to see the moon and the craters, Jupiter and Saturn, before they take the next step and say, okay, I want better quality next, you know. Anyway, okay, so in this short test, this one came very close. Okay, very close. I'm talking about 10% this. And remember, our eyes can't always tell. They say our eyes can't tell anything less than 9% is what they say. So it's very close to like a long format. Now, I do think, though, it would be maybe a slightly bigger chance if I had one that had a parabolic mirror. That would be a different video. I don't have that kind. But between these two, I would say then pick whichever one. If you like the portability of it, get that one. But if you want something just a little tiny sharper, and the longer ones are a little bit easier to collimate, then maybe get that one. They're also very cheap too, the long version ones, because again, they're coming with the spherical mirror, but they're long, but it also keeps the price down. So again, anyway, let's end this video. That's long enough. Anyway, guys, like, comment, subscribe. And if you see anybody that's asking questions on the forums and I have the video, share my link with them. Why not you? Why not me?